Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to discuss a class 9th topic. The name of the chapter is Matter Around Us Pure? And the topic's name is Exemplar Problems Part 2. For Part 1, please check the I button and the link of Part 1 has been given in the description box. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video and share this video with your friends also. So now come with me and let's crack chemistry. Our topic is short answer questions of exemplar problems. Students, in part 1 I explained 9 questions. So this is the 10th question. Question 10th is that suggest separation technique or techniques which you require to separate the following mixtures. You have been given a mixture of mercury and water. Students, before explaining this question, I want to make few points clear here. Always remember that separation technique depends on the difference in the properties of components of mixture. For example, if you have a mixture which has two components, out of two components, one is soluble in water but the other is insoluble. So you can separate the components of mixture by dissolving that mixture in water. What will happen? Water soluble component will go into water, leaving behind the insoluble component. Now, the insoluble component can further be separated by means of filter paper. Similarly, we have various other separation techniques which depend on the difference in properties of components of mixture. So now I will discuss the question which is given here. In this question, you have been given mercury and water. So all of you know that mercury is a metal which exists in liquid state at room temperature, and mercury is denser than water. So when two components differ in their density, we can use separating funnel. So now let's see what is a separating funnel. Students, in this diagram you can see a separating funnel. This is the diagram of a separating funnel, where you can see a knob is present in the lower portion, which is used to remove liquids from separating funnel. The mixture to be purified is placed inside separating funnel from the top. So we have placed the mixture of mercury and water in the separating funnel. As you know that mercury being heavier will form the lower layer and water being lighter will form the upper layer. So in the upper layer you have the lighter component which is water here, and in the lower layer heavier component will be there which is mercury here. So once mercury and water forms two different layers, we can separate mercury by opening the knob, and once the entire mercury is collected we will close the knob, so water will be left behind in the separating funnel and the mercury is separated out. I hope this method is clear to you. Next question. Suggest a separation technique to separate a mixture of potassium chloride and ammonium chloride. So as I discussed with you, again we will see the physical properties in which these two components differ. So ammonium chloride is a sublimable substance. Sublimable substance means it undergoes sublimation. Sublimation means it will convert directly from solid to gaseous state. And potassium chloride is a non-sublimable substance. Now let's see the experimental setup which is used for separating the components of this mixture. Children, in this diagram you can see the experimental setup. In this experimental setup you can see this is a bowl-like structure which is called as china dish. In this dish we have placed the mixture of potassium chloride and ammonium chloride. On the china dish, a perforated asbestos sheet is placed, and on this perforated asbestos sheet an inverted funnel is placed. The stem of the inverted funnel is plugged with the help of the cotton, and you can see this is the Bunsen burner which is used for heating the mixture. So once we start heating the mixture, ammonium chloride, which is a sublimable component, will convert from solid state into gaseous state directly. So you can see the vapors of ammonium chloride rising up. When these vapors come in contact with the comparatively cooler surface of the funnel, they will again convert from gaseous state to solid state. So once we see the entire ammonium chloride has sublimed, we will stop heating. And we can separate ammonium chloride from the inner walls of the funnel by scratching it out. So we can see that potassium chloride is left behind in the china dish and ammonium chloride has been separated after its sublimation. I hope this is clear to you. Children, next question is how you will separate components of mixture of common salt, water and sand. So we will do the same thing as we did in the previous cases. We will find out the difference in properties of components of mixture. So the given mixture contains common salt, water and sand, and we know that common salt is soluble in water, whereas sand is insoluble in water. So what we will do? We will take this mixture and this mixture will pour on a filter paper. So as the common salt is soluble in water, its particle size is less than 1 nanometer. Common salt in water forms true solution. So it will pass through the filter paper and will be collected in the form of filtrate. And the sand, whose particle size is larger than the pore size of the filter paper, it will retain on the filter paper in the form of residue. So whatever points I discussed with you are written here. Sand is water insoluble, common salt is soluble in water. So common salt will get dissolved in water and the sand remains undissolved. This can be understood with the help of following figure. In this diagram you can see that the beaker contains a mixture of common salt, sand and water. This mixture is poured on a filter paper. So sand particles being larger in size will remain on the filter paper in the form of residue, whereas the solution containing water and salt will pass through the filter paper in the form of filtrate. Now we have separated sand. Sand will be collected on the filter paper, whereas the filtrate contains common salt and water. So now how we will separate common salt from water? Common salt can be separated from water with the help of simple distillation. So what is simple distillation? Simple distillation is used to separate those mixture where one of the component is volatile and the other component is non-volatile. Apart from this, simple distillation can also be used to separate a mixture of two volatile liquids whose boiling point differ by 25 degrees or more than 25 degrees. Now the mixture of salt and water can be separated by the process of simple distillation. You can see that the apparatus which is used for simple distillation is shown here. In this apparatus, a round bottom flask is there which is called as distillation flask. The mouth of the distillation flask is closed with the help of cork. Cork is having one hole in which thermometer is fixed. And the round bottom flask is fitted with a stand with the help of a clamp. And this distillation flask is attached to a condenser with the help of the side arm. And you can see that in the condenser there is an inlet for the supply of cold water and there is an outlet through which the hot water goes out. In the other end of the condenser, a receiving flask is placed which collects the liquid after condensation. So mixture of salt and water is taken in the distillation flask. Now we will start heating the components of salt and water. Water being volatile will convert into vapors and these vapors will rise up. And these vapors after rising up will pass through the side arm. Here they will be cooled by the water which is supplied through inlet. And the water which is supplied through inlet will cool these vapors. After cooling these vapors, the water will become hot and this hot water goes out with the help of outlet. So with the help of this condenser, the vapors of water will undergo condensation and will be collected in this receiving flask. We will stop heating once the entire water vaporizes and collected in the receiving flask. With the help of this process, we have separated the mixture of salt and water. Salt remains in the distillation flask, whereas water is collected in the receiving flask. I hope it is clear to you. Next question is, you have to separate components of mixture of kerosene oil, water and salt. As you know that salt is soluble in water. So salt will get dissolved in water, whereas kerosene oil remain insoluble. So kerosene oil being lighter will form a separate layer. So we can separate kerosene oil from mixture of water and salt using a separating funnel. So what we will do, salt will get dissolved in water and the kerosene and salt and water will be placed in a separating funnel. So what will happen? The kerosene and water, they will form separate layer. As you know that kerosene is lighter. So being lighter, it will form the upper layer. What about water and salt? Water and salt being heavier, they will form the lower layer. So this is shown in this diagram. So upper layer will be formed by kerosene, which is lighter, and the mixture of salt and water being heavier will form the lower layer. So what we will do, we will open the knob. With the help of the knob, we will collect salt and water. So we have separated kerosene oil. Kerosene oil will remain in the separating funnel, and the mixture of salt and water we have separated out. Now, how you will separate the mixture of salt and water? We discussed in the previous question, mixture of salt and water can be separated by simple distillation. I hope it is clear to you. Now, consider the next question. In this question, you have been given two tubes and they are asking you that which tube out of A and B will be more effective in the process of fractional distillation. Children, before explaining this question, I will show you the apparatus which is used during the process of fractional distillation. So children, this is the apparatus which is used for the process of fractional distillation. Fractional distillation consists of exactly the same apparatus as we discussed in the case of simple distillation. Only one difference is there, that the distillation flask is fitted with a large fractionating column, and you can see that in the fractionating column it is filled with glass beads. So what is the purpose of glass beads? These beads provide more surface area for effective cooling. So what happens? Fractional distillation is used for separating components of those liquids where the liquids differ in their boiling points by less than 25 degrees. Once you start heating the mixture where its components differ in boiling point by less than 25 degrees, on heating, vapors of both the liquids will rise up as the difference in boiling point is less. So what will happen? The vapors of both the liquids will rise up, but on rising up, they will pass through the fractionating column. Fractionating column is filled with glass beads. Glass beads provide more surface area, as a result of which the vapors of higher boiling liquid will condense and will fall back into the distillation flask, and the liquid which passes through the condenser will be rich in the lower boiling liquid. Liquid which is collected in the receiving flask mostly consists of the lower boiling liquid. Now this liquid is subjected to fractional distillation again. Finally, we will get the pure liquid component which was having the lower boiling point in the receiving flask. So as the process is carried out in different fractions, it is called as fractional distillation. So now I am coming back to the question. The question is that which of the tubes will be more effective as a condenser in the distillation flask? You can see that the fractionating column A is fitted with glass beads, which will provide more surface area for cooling, whereas fractionating column B is empty. It's not filled with glass beads, so the purpose will not be solved. So tube in figure A will be more effective as a condenser in distillation apparatus. I hope it is clear to you. Children, thank you so much for watching this video. I hope each and every point is clear to you. Post your doubts in comment box. Please subscribe my channel and press the like button if you like this video, and share this video with your friends also. Thank you so much. Have a nice day.